Section 5.5, Products and Quotients of Rational Expressions. The one objective here is to multiply and divide rational expressions. There are some simple steps we can follow to help us along the way. If the operation is division, first of all, let's rewrite it as multiplication by the reciprocal. Remembering multiplication by the reciprocal here. The first step is to factor all the expressions completely, and then cross-cancel or vertically cancel common factors. So again, we need to factor things to cancel. Remember, we looked at that already. When we simplified expressions, then we're going to just simply multiply across what remains, and then simplify or modify the final answer if need be. So let's take a look at an example of this and see how this is pretty much the same thing as simplifying rational expressions, but now we're multiplying and dividing, but in the same sense, we're still just simplifying. The first example says to find the product below, and we can see that we have a complex operation here, but what we notice right away is that these can all be factored. Okay, so let's start by factoring everything, which is step one. So in the upper left, I'm going to say I can take out a 3x up here, leaving behind 1 minus x. In the bottom left, I'm going to see that this will factor simply into x minus 1, x plus 5. Then on the top right, we're going to have x plus 5, x minus 4. And then finally in the bottom, we leave this as 3x. And what we'll notice is step 2 says to vertically cancel or cross-cancel if we can. Well, what we'll notice here is that these cancel. Those are cross-canceling. These are cross-canceling. Well, why can I do that? Let's think about this for a second. Why can I actually do that? The reason being is, remember when you multiply two fractions, you just multiply the tops and you multiply the bottoms. So you could pretty much just do this. This is like one big fraction line, because there's really a multiplication symbol here, and there's really one here as well, if we just put everything next to each other. So when we're cross-canceling, like I just showed you, in reality, this cross-cancellation is still like vertical canceling, you know? This is the numerator, is the denominator. Numerator, denominator, we're canceling. Now the last thing we have to notice is this. This quantity here, 1 minus x and x minus 1, those are related to one another. If you think about it for a moment, I can factor a negative 1 out of the numerator, out of this term, or this factor up here. If I factor a negative 1 out, I get negative 1 plus x. Well, negative 1 plus x is the same thing as saying x minus 1. This is really x minus 1. So again, rewrite this as x minus 1, and that's what we have up top now. And what you'll notice here is that these cancel. We leave behind this negative 1. So our final answer we leave behind with a negative 1 times, right? That times comes from here, this times, this x minus 4. And there's nothing left on the bottom except for a simple 1, so it's all over 1. Right? This is gone, this is gone, this is gone. There's 1's left behind when I cancel. Well, this was gone, by the way. We rewrote this as this up here, and then we rewrote this as this. So all of this is gone. The only things that are left are the things that I've circled. Okay, this negative 1 and this x minus 4, and it's all over the quantity 1. So this is the answer here, and I can simply rewrite this as 4 minus x. Okay, again, multiplying this out. That'd give me a negative x plus 4, which is simply 4 minus x. In example 2, we have a division problem, so remember that if it's division, let's multiply by the reciprocal. So we'll start by switching what's going on here. Put times, and then just invert the fraction. And then we proceed the same way we proceeded in the last problem by factoring. So the 7x remains. You can factor out a 2 here, giving x minus 5. And up top here, we're going to factor this. We'll see we get x minus 5, x minus 6. In the bottom, factor into x, leaving behind x minus 6. Well, take a look. A lot cancels here. These cancel, right? Because again, now this is just one big fraction, remember? It's like one big fraction when you're multiplying. These cancel. This x and this x both cancel. Leaving behind, all that's left is a simple 7 over 2. Right here, that's all that's left. Everything else canceled. So the final answer is 7/2, or 3.5. And finally, example 3 says to perform the operations below. So we have multiplying and dividing. So We'll start by factoring everything, and we can actually flip that last fraction at the same time. So again, let's rewrite this as a times and flip this fraction, but we'll factor at the same time while we're doing that. So this first part factors into x plus 4, x minus 4, simply because that's the difference of two squares. The denominator, we can use AC method to factor, giving us a result of 4x plus 3 times the quantity 3x plus 2. In the numerator in the next part, we're going to get 3x plus 2 times the quantity x minus 7. The denominator factors into x minus 7, x plus 4. Now remember, I'm going to factor this part here, but I'm going to put it in the denominator for this last part because I'm multiplying by the reciprocal. So, again, the factors of x squared minus 2x minus 8 are going to go down here. And that factors into x minus 4x plus 2. And then the factors of this term here are x plus 5x plus 2. They're going to go in the numerator because we're flipping that again. And then we see we have a lot of cancellations happening here. These cancel, these cancel, these cancel, and these cancel, and finally these cancel, leaving behind only the x minus 5 and the 4x plus 3. I'm sorry, x plus 5 and 4x plus 3. Your homework from this section is from 5.5 and some review exercises from section 2.4.